Okay, so this lecture today is one of the last lectures on code correctness. And in fact, if you look back on the lecture slides on WebCMS3, you will see that this is the last correctness lecture. So we've had a bit of a long journey here on the topic of correctness, because if you remember, essentially, it was a topic around how we make software that is safe and reliable, and how do we verify that the software actually works. So this last topic is called code coverage. Now, the reason it's called code coverage is because so far when you've been writing tests, you've really been focusing on just you coming up with your own ideas, but we need more automated ways to tell if your tests are good. And in some ways, this is going to be a very similar lecture to when you learned linting, because you kind of learned what good style is, and you did a lot of that manually, and then we came along and we said linters are tools to help automate that. So today, we will be looking at a mechanism to tell how much our tests actually test. Because how do you know if your tests are good, right? You only know because the auto marker tells you whether your tests were good or not. But there's actually much more depth to test writing than that. And things that you can figure out without any auto marker. Because in the real world, you don't have an auto marker, right? Your tests are your own auto marker. We'll be talking about coverage. We'll be talking about coverage broadly as a topic. We'll be talking about code coverage as a type of coverage, and we'll be talking about code coverage in jest, because a lot of the correctness we look at when it comes to code coverage is done in the context of jest, which you're already familiar with, which makes your life a bit easier. So, firstly, coverage. Coverage is a measure of how thorough our tests are. Makes sense. I said before that we, auto mark your tests, I think I might have said. That's not really the case, right? Like if you think about your project, we actually just auto mark your implementation. You write your tests to help your own implementation, but we don't actually check the quality of your tests automatically, right? There is no automated process we have for that. Your tutors just look at your tests and kind of get a sense of whether they're good or not. You could argue that your tutors are actually looking at the coverage of your tests. In fact, we asked them to. We asked them to go through your source code on GitLab and to actually give you some of the marks based on how decent the coverage is you have for tests. So if you have tests that they feel cover a lot of use cases, a lot of different potential outcomes, then you get extra marks for that. There are two types of coverage though, generally. The first one is what we call test coverage, and test coverage is a measure by which we check how much of a feature set is covered with tests. And this is actually what your tutors do. So I mentioned that your tutors look at coverage, and this is typically what we would call as test coverage. So your tutor kind of looks at your test code, and then they say, yep, I can see that they're testing register, and they're testing that register might fail in these few cases, and then they're testing channels create, they're testing all these different things. And it's a very high level thing. And again, it is very human in nature. And it's quite literally nearly looking at a spec and then coming back and looking at your code and just very vaguely getting things. And then there's code coverage, which is really the crux of what we're talking about tonight, which is a measure of how much code is executed during testing. So it has no awareness of the spec, because test coverage is kind of a human looking at the spec and then a human looking at your code, your test code, and going, did this cover all the use cases, all the possible outcomes? Whereas code coverage is a computer looking at your code and your implementation and seeing how much of your implementation was actually tested by going line by line. And it can be completely automatable, which is why it's interesting. The simplest way to imagine code coverage is if you have a piece of code that is 100 lines long, maybe like 10 functions and 10 lines each in those functions, and then you go and have tests over here that call those functions and test it, what code coverage does is it essentially checks, was every one of those lines of code you wrote in your implementation, were they explored by all of the tests collectively? Did at least one test go through at least one line, each line of code? And therefore, we kind of measure code coverage often in a simple way as the number of statements, the number of lines of code that are executed. So if you've got these 10 functions with 10 different lines of code in each function, you could say that your code coverage is just a measure of how many of those 100 lines of code did your tests actually go through? How many did they execute? How many did they call? This gives us a good indication of how much of our code is executed, but more importantly, it helps us understand what code is not executed. So it's not just the percentage that matters to us, it's actually coverage tools being able to tell us, hey, this line of code that you wrote was actually never executed, and that's kind of a problem. So we can actually do some code coverage checks pretty easily. And for that, I might go back to some of our previous weeks. So if I go to, say, 1531, let's go back to some of our week 2 code, or week 3 code, right? So we have a few different things here, and you can see that I've got a file. What test files do we have here? Let me see. Okay, we got this 2.3 jestlib.test.js, right? And you can see that this particular file here it was calling our jestlib, which if we have a look at that file, was a pretty straightforward function that hasn't been implemented. Probably got rid of the implementation. That was a little bit silly. That's okay. Let's actually quickly inspect these files. Let's make sure. So I do think we had the implementation hiding somewhere from memory. And we'll see if it's still there. Sometimes I don't save the files from the lectures, just because, you know, we kind of butcher things in the butcher things in the middle of a lot of our lectures. So if we drag this out, what do we got? So we got a few different files. I think we only have one of these has tests in it. And all the remove vowels ones don't seem to be implemented. That's okay. We can quickly implement that again. So if we do have this function, which is our 2.3 jestlib, and then we have a jestlib test here, our remove vowels function, how could we remove some vowels? How many people do we have here, by the way? Excellent. Handful. If you were to remove some vowels again, you probably know by this point. Also, by the way, one thing you can do, and you've probably done this before, is like, if you want to really crudely test a file, you can just put console logs in that file at the bottom, just like temporarily. I'm sure nearly all of you have probably figured this out, right? So you can kind of just write something like that, and then run your code directly against that. So, you know, over here, if I go into our, or I can run, you know, node source 2.3 jestlib.js. Okay, and I get 0 because, you know, the function's broken. But if I then say, you know, string equals string.replace a with nothing, we will have removed the vowel. Oops, sorry, return string. Now there's probably some linting rules here that they don't like that, and that's okay. And we'll just do that for the 5 vowels. And yes, there are cleaner ways to do this, but let's just get this together for now. Okay. Great, ABC removes that, so we know that works. Now we want to run our test. So how do we run our test? Well, I can run npm run jest source/2.3 jestlib.test. So there's that test file I can run. And it's missing a script because I don't have the node modules installed. So I need to do an npm install here, which will go and install all the modules. Thought this was already done. My apologies. And you'll see the test results quite straightforward. And you should be very, very familiar with this kind of pattern, right? This at this point, you're kind of like, sorry, I don't know. Let me just add jest manually here. Yep. Okay, so what can we see here? We can see that our tests are failing. Oh, that's annoying, right? Deals with no vowels, deals with starting vowels. Things aren't really working. So what do we see? What ones fails? Deals with starting vowel. We expected old to return that. Now, why doesn't it do that? What happens if we pass in old? See if this passes more tests. So we're failing 3 tests at the moment. Oh wait, sorry, I wanted to run the code directly. Sometimes Jest can be a little bit slow, so you know it might actually be quicker to run the code directly like this, and we get LD. So clearly something is wrong with the import, probably. No, I'm not sure. Not exactly sure why this function is failing here. This doesn't make a lot of sense. If we're running the right file, we're running our test lib, yep. We call it with old. Did I misunderstand the function? Is the function meant to not remove? Maybe I probably just didn't actually finish our test last time. Let's try it now. Yep, only failing 2 tests, and you can see that B turns into BE. B doesn't. Okay, this makes sense. So the string.replace here looks like it's only replacing 1. Now this is the kind of thing that, again, most of you are probably like, I know that. And if in my case you haven't played with that function for a few months, it's easy to forget. I just wanted to run the file directly. So you can see that replace here looks like it only replaces 1. How do you normally get around this? I look up replace string JavaScript. You go look at the API documentation online. W3 schools, typically like the MDN site's really the, where all the proper rules are. But I guess it's only replacing 1. Does it take in a regex substring? It's interesting. I'm not sure. Every language has its own replace function. There's probably another function, something else. Doesn't really matter. We can wrap it in a for loop or something. I should probably read this properly. Returns a new string with some or matches of the pattern. The pattern can be a string or regex. So, hello Clayton says using regex end with G for global. So that's the thought I'm getting here is that the substring method, only the first occurrence will be replaced. Okay, sure. So it looks like a limitation of the way this works in JavaScript, right? Normally when I do replaces, I'll use a regex. Like I'll do something, I'll do some kind of regex string, like, where's the examples they have? Regex is not part of this course. It's something we do actually teach inside of 2041, Comp 2041 if you want to take that particular course. But we can see if this works fine. So let's just quickly replace all of these with some regex. Regex is a language that kind of just describes patterns of strings. Clearly that is wrong because I've got these quotes here. Okay, there we go. Now this should pass all the tests. Maybe you need the G, maybe you don't. Not too sure, and then you can see that it expected that to turn into that. I think that might be a typo. So back here we go. And now we got our test working. This was just to demonstrate a point. Fairly straightforward. We have our test passing. Now, bit of a tangent, but if we come back here, one thing about Jest is that you can actually add the -- coverage flag to it. There are other programming languages like, I think Python's a good example where, when we used to teach this course in Python, you used to have a different library for your coverage. So you'd have like your Jest testing library, and then you'd have your like coverage library, which would be used in conjunction with Jest. Whereas Jest has the coverage command built in. So when you run, instead of just running Jest and then a file, you can run Jest -- coverage and then a file. And that looks like it was parsed out, which is kind of annoying. So you probably have to add it to the script itself. So if I just modify this, Jest, because if we just run Jest by itself, right, it will run all the tests in the file. npm run Jest, because that's what I've defined in the package.json here. Yep, so it ran all one file that existed. I got to get rid of this console log. And now if I want it to use the -- coverage, I go and open up my package.json, and then I can add it here. Like this. Now obviously test and Jest do the same thing in this case. But now when I run it, it's running it with the -- coverage command, and you will see what's really interesting here, and this is where the meat of things really start. It's not just that it ran the tests and it showed us the successes and the failures, but it actually showed us all of this information here. Now let's dissect this together. A few things to point out. Firstly, all files is just a summary of the different files. In fact, to give you an example, let me go and take our test file here, and let me go and create another one called 2.3 jest lib test2. And what I'm going to do is in this one, I'm going to keep a couple of tests. And in the first one, I'm going to get rid of those 2 tests. So we're basically just splitting these tests up across a couple of files. So just to show you when I run it again, you'll see that it will give you a summary of the results for all the files. I think I named that poorly. I did name that poorly. Sorry. I named it underscore test instead of 2.3 lib2.test.js. It's kind of a terrible name. So we run that again. We should actually get 2 results now. Nope. What have I named it? What have I done? Very strange. Oh, no, it did. Did it run both? lib2 and lib... Not sure why it only showed one here. That's kind of strange. We can see that both tests ran and both files passed. Not 100% sure why we're only seeing one file here. But the point is that this part here is the coverage part, right? And this is essentially saying for each file, how many lines of code did your test go through? Now let's imagine for a second here that you have the remove vowels function has another condition, which is like if there is a number in the input string, return undefined, right? Imagine this is part of the spec or something like that. So if there's a number in the input string, then return undefined. And what is interesting here is how would you implement this? You would say, well, you know what, if the string, dot includes, I can't remember if dot includes works out of the box, probably not. 0 or something, or in fact, we could probably actually use regex for this. For those of you who have been curious about regex, again, regex is a particular language that you can kind of teach in your own time, but basically it's a very powerful way to look up strings. It's not assumed knowledge in the course. You don't have to learn it, but there are some very helpful little pieces of code that will help you I'm sure the example was right in front of me then, but I just want something quicker to look at. Yeah, so very simple one here. You can actually write a statement to say like check if something's inside something else, and I'll just show you here. So one really easy thing to do with regex is to actually, it doesn't really matter, I can write it out, is you actually say, you know what, hey, if some kind of like, I've clicked a button on my keyboard, now everything's not, the cursor's not working. Very strange. Okay, you basically say, you know what, if a pattern dot test, and then you, let me save this file and reopen it, it's so difficult. Yep, if pattern dot test, and then you give it the string. And the pattern here is actually a piece of regex. So kind of by default, what this really says is like, hey, if you can find an A inside the string, then, return undefined. That's quite literally what it is, except regex is quite a powerful language. So what you actually want to say here is not just A, but you actually want to say, hey, A or B. So this is some regex for A or B, if any of A or B, or you can say any of 0 or 1, or 2, or 3, or 4, or 5, 6, 7, 8, 9. Now we have all the numbers. So it's like, okay, if any of these numbers appear in the string, then we want to return undefined. Now, what's interesting is like, let's say you have some code like this. Oh, crap, I saved that file again. Let's say you do have some code like this, and you now run your test coverage on it. Let's pay attention to what happens, because we've got our 2 test files. Those 2 test files run through all of your implementation. And what's interesting is that you see the results here have changed. So now instead of saying 100%, it's actually saying, you know what, hey, on your 2.3 jest lib, I might rename this to see if it comes up. I'm not 100% sure why it so weirdly doesn't want to display. 2.3 jest lib test2, call this blah.test.js. Okay, we'll just give it something really, really random. See if it appears twice here. Maybe not. Nope, very strange. There's probably a configuration missing. So because this term we moved to a totally different coverage framework, there's a few things that we're still figuring out, and me still figuring out specifically, because it's pretty similar to other things we've dealt with. But the core is still the same. This is your coverage result, and you can see that for 2.3 jest lib.js here, it's saying that 87.5% of the lines of code, if we come back to your implementation file, 87.5% of those lines of code were basically run. And what it's saying is that 50% of your branches were run, interesting, 100% of your functions were run, good, and 87.5% of your lines were run. So lines and statements are kind of the same thing. Not literally, because you can write a statement of code over multiple lines, but for the sake of what we're dealing with here, you can kind of picture that lines and statements are exactly the same thing. And it will tell you the lines of code that were not run, in this case 5. This is interesting because it's not that the if statement wasn't run, because the if statement is always run, because the program actually has to pick the if statement, right? Like it has to execute it. It has to run the condition to decide whether to not enter the if statement. But because we didn't test with any numbers in our strings, it never actually went inside, and that's why line 5 here was never executed. So hoping this starts to help paint the picture that coverage is where it's a program that watches your implementation while your tests run against it, and it tries to make sure that every line, tick, 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 was actually executed. And in this case, it found a line of code that wasn't executed. And the reason this is useful is because this is a common source of bugs, is you writing code that is never tested. So what this coverage output is saying is like, yeah, you have code in your implementation. I get that your tests are passing. I get that, you're happy you got your 100%, and that it's all good, but you need to understand that there's something in here that's not tested. There's something in here that could be broken. So then we would go away and we would go and open our, blah.test.js, and we would go and test something, right? Test returns undefined for numbers. And then we would have, ABC123 to equal undefined, like that. And then we would run our tests again, and we should get full coverage this time. Yeah, so that's good. That tells us what we want to see. Very good. 100% because we executed all those lines of code. That's pretty straightforward. Let's jump back to the slide. So this coverage in this case, like if you imagine that remove val had that extra piece of implementation which required you to return undefined in the case of a number being in the string, then this just helped us write better tests. There is another piece of code we can look at, and this time we're going to have a look at it in the context of TypeScript. Obviously, this will pretty much be exactly the same, but this is a piece of code from week 7. So if I go pull up that particular environment in week 7, whoops. So we go pull this up. Let's have a look at a piece of code. 7.1 is leap year, right? How would you test this? Now, I know we say to you all the time, you need to write your test before your implementation, but you kind of know this already. Sometimes you write your implementation before your test. Not wholly. It's not like you write your whole implementation. But I'm sure you've all been through it. You write your test, you write your implementation. You then realize later something's missing. So you go and add that missing thing in, and then you got to test it more. Or maybe you don't test it more. Maybe you just kind of leave it alone, which would not be ideal, but that's okay. So in this case here, let's say we have a function called isLeapYear. Now, isLeapYear function is fairly straightforward. You give it a year, like a number, like 2022 for 2022, and it will return true or false if there is a leap year or not. So let's go and write a test file for it. That test file I'll name 7.1 is leapyear.test.ts. Like this, and then we'll start going, doing our thing. We'll go and import the function. We'll go and import isLeapYear from 7.1 is leap year. Should be easy, and then we can start doing our testing. So describe testing leap years, and then we'll go and do our test. So we'll start writing test for what would you say? Testing. What are some leap years? Testing, or we want to test recent years. Something really simple. So we say expect 2022 to be equal to, or to be false. Or it doesn't really matter for that, right? Or 2011 should be false too, and 2020 should be true. Okay, and 2019 should be false, and so forth, right? 2018, 17, 16. So you can kind of, this is, you wouldn't maybe write this many out, but just trying to convey a point. We've got some tests here. Okay, great. And they're testing this particular function. Great. So now we'll come here and we will, let's open up our package.json and let's add another line just to particularly test this file, called like week 7 test. And this will just run the jest command, in source/7.1 is leap year .test.ts. Okay. So now when I run npm run week 7 test, it should run that line of code. Great. Oh no. Got this annoying problem that I had sometimes. That's okay. Let's just double check I'm doing the right things. Yep. Let's try one more time. That's a pain. That's a pain. That's okay. We can pull this example off pretty quickly. If you give me a short moment. So basically here, just got to clone this repo. Give me a short moment. Okay, so just a quick recap. We're having trouble with the CSE machine. So, just running this one locally for the moment. And there was just a little bit of a silly moment where we forgot to add these in. Now, I'm not going to add them all in because this is wasting time. But what we have here, right, 2022, 2021, that was an absolute hilarious one. I won't forget that one. Why is 2022 not false? So we run this again. This should work this time because we're not trying to check if 2022 is a Boolean. Thank you. And you can see that it's true. So we wrote some tests. We passed all the tests. And this example is trying to illustrate that problem you've probably all experienced where you write some tests, your tests succeed, and then you get your auto marks back and you got 80%. How do we bridge that gap? You've written all the tests you think you have to write. We can't stop you from, we literally just can't stop you from not interpreting the spec correctly. That's just an important skill in life you have to figure out yourself without us. But we can help you figure out if you've written an implementation that has not been thoroughly tested. And you can do that, obviously, by adding your -- coverage to your jest command that you run. So now by adding -- coverage here, and I run this week 7 test, it's kind of annoying because this text actually appears in yellow, so I'm going to have to change my terminal color, finally, away from this beautiful color of yellow to maybe, I don't know, blue. That is ferociously terrible. Gray? These are all very bad options, but we can go with them. Let's run it again and get some better formatting. Okay, not the favorite color. We'll change the color soon. But what you can see here immediately is you can see that it says that 7.1 is leap year. 66% of the statements covered were tested. 50% of the branches, whatever that means, 100% of the functions, and 60% of the lines. And it says that uncovered lines were 6 to 9. So now I can go back to my code here and I can say, okay, 6 to 9 are the lines of code not covered. So that's interesting. Now there's another file we'll check in a second, and I don't think we get into this. We'll get into branch coverage later. But for now, if we're testing this code, and let me maybe pull it up in a separate terminal, in my second gray terminal. env2 and no source slash 7.1 is leap year.ts. Okay, so we got this code here on the left, and it says that we have not covered lines 6 to 9. So this is really useful because it immediately starts to tell us what goes wrong. Let's trace through the code. If a leap year, when divided by 4, is not equal to 0, then it is not a leap year. So that's a pretty straightforward rule to start. Basically, if your year is not divisible by 4, it's not a leap year. We have an example of that. And in fact, this is where you can actually go back through your tests and you can actually try and write them in that particular order. So you could say, I'm going to forget this whole recent years thing. Let's actually say test for years not divisible by 4. And then you can start trying to test if years divisible by 4 for instance, like let's take a year not divisible by 4. 2001 should be false, right? A year that is also not divisible by 4, 1997, you know, pretty much any odd number. So maybe let's test some even numbers, 1998, few of these other things. So now we're testing that the years are not divisible by 4, but we already kind of did that in the first example, so that's not going to help. The next one says, if the year is divisible by 4, and it's also divisible by 100, then return true that it is a leap year. So this is kind of interesting because when this one, it's inverted logic always gets me. No matter how many times I do this example, I get completely stumped by it. If a year divided by 4 has a remainder, right, it's not a leap year. However, if it does have no remainder, as in it is divisible by 4, we have to check, is it divisible by 100 with a remainder? Right? What are some examples of this one? In fact, try and throw out a few examples of things you might test. And you can kind of see implied from the implementation here that being divisible by 100 and being divisible by 400 are two kind of boundary cases. So I can immediately start to write some of those tests out, right? Test years divisible by 100. Like this. See if anyone has any ideas. But otherwise, let's try this out. So like here's an example. 2000 was a leap year, right? 2200 is going to be a leap year as well. But the year 2100 is quite interesting. Because 2100, is that divisible by 4? Unless I can't do maths. It is divisible by 4. So 2200? Oh my god. It's everything. No, they're fine. Right? So, what do we got? It's so the funny thing about leap years is that every 400 years, I can't verbalize this, I have it in my head. Every 400 years is a leap year, I believe. But every 100 years is not. So like if we pull up, just to paint this point, like let's test it out with a calculator here. We've got like a leap year checker online. This will kind of help. Also, this is a really great way to test. It's something we don't actually talk about a lot when it comes to testing, which is that one of the most common ways that tests are done are actually just by benchmarking it off previous things that were tested. So in this case, I'm like, all right, is 2022 a leap year? It's a common year. Is 2100 a leap year? No. Is 2400 a leap year? Yes. So, okay, there we go. Got the articulation in my head. So it's like, what we have to be careful of here is that if you're divisible by 4, you might be a leap year. But if you're divisible by 100 as well, you're not a leap year unless you're divisible by 400. So 2000, 2004, 2008, 2012, 2016, 2020, these are all leap years. 2096 is a leap year. 2100 is not. 2104 is, 2108 is, all the way up to, 2200, which is not. So we should be testing here for years divisible by 100, such as the year 2100, that it is not a leap year. And 2200 and 2300. But here's the other kick. If the year is divisible by 400, it is still a leap year. So it's kind of like, if you think about the 100, everyone gets the even thing, right? If it's not even. If it's divisible by 4, it's a leap year. The year 100 was not, 200 was not, 300 was not, 400 was. 500, 600, 700, no. 800, yes. 900, 1000, 1100, 1100 is not. 1200 is. 13, 14, 1500 is not. 1600 is. 1700, 1800, 1900 is not. 2000 is. So we can test a few of these cases as, 2300, 2500, and then our last test will be years divisible by 400, which is where we can just check for our kind of, standard edge cases of the year 2000, which should be true, the year 2400, which should be true, the year 2800, etc., right? So, 1900 was not a leap year, even though it is divisible by 4. Now, in theory, when I go and run this again, we should see a whole bunch of, passes, which is good because now we've covered all those use cases. But you'll see if I go and comment out this particular line of code here, this particular test, which was our 400 one, and I run it again, you'll see we do better than our 66%, but we're now at 88%. So we're at 88% of lines, and it says the uncovered line is line 9. And line 9 in this piece of code is right here. So there's our piece of code that was not actually run, line 9 there, return true. And this makes sense because if you go look at all the other tests we're running, some of them go into this if statement and then return immediately. Some of them go if, else if, and then return immediately. Some of them went if, else if, and then return immediately, right? But no one ever made it to that last one because that last one you only get to if your leap year is if it's divisible by 4 and it's divisible by 100 and it's divisible by 400. Because if you're not divisible by 4, you end up there. And if you are divisible by 4, but not divisible by 100, you end up here, which makes sense. That's all our 2004, 2008. And if you are divisible by 4 and you are divisible by 100, but you're not divisible by 400, such as 2100, 2200, 2300, you return false. And then if you finally make it to the end, you must be divisible by 4, divisible by 100, and divisible by 400 all at the same time. And that's where we get our return true. Now, we talked about this whole lines of code thing. I don't know if I'll be able to demonstrate this super effectively. I haven't tried to before, but let's try it out. If I say put these on different lines of code, this is obviously terrible style. See if we get a different thing with statements and lines. No, we don't. That's okay. If you go study like the theory of programming languages, you learn about that, code is made up of expressions, and those expressions can be part of statements, and, those expressions or statements can be over multiple lines of code. There's kind of a whole programming theory-ness to that. And you can kind of see here that it did show that, when we split it up, lines 9 and 10 were bad. What is kind of interesting, though, about coverage, and I didn't talk about this because I wanted you to understand it at a more basic level. But let's actually go all the way back to our first example for a second and run that one. Right? What we didn't talk about was that when you run coverage and you get these results, in this case, for instance, it says 100, but if we go back to our previous example and we get rid of that test here. We get rid of that test that was checking for that edge case of the numbers, and we do get a result that says like 87%. What's really interesting is that if you actually ls, look at all your files, you actually see there's a folder that's been added called .coverage. Now I don't think this is a Git repo. Yep, it's not. So if you go inside your .coverage folder, you'll actually see a whole bunch of stuff here. But the file of interest is inside the L coverage report, and there's a file in here that's index.html. And you can actually open that straight from the command line by saying, Firefox or something else, coverage, lcov report, index.html. And what this is actually a web page. It's actually like a website thing. It's a static web page. It's like when you file save a website on your computer locally and you can load that up locally. So it's a local file, but it is produced every time you run the coverage command. And when I open that up in the web browser, it actually gives you kind of a more detailed, more visual explanation of what's gone wrong. You notice this is kind of just like a pretty version of what's on the command line, where we can see that, okay, 7 out of 8 statements were executed, 100% of the functions were executed, all of that. It gives you a little nice green bar. But most importantly, you can click on the file, and if there are many like if you're for your project, you're going to have many files here. Your auth.ts, your server.ts, your channels.ts. When I click on my justlib.js here, it actually gives you a visual summary of what's gone on here, which is that it's like, yep, everything here is good, except the red lines are the lines of code that weren't executed. Now, there's not really any extra information here than what's on the terminal, because obviously the terminal up here did tell you that it's line 5, but the terminal display you wouldn't exactly call, very easy to read. Now, obviously, so hello, Clayton says, wait, how do we open the HTML in the browser again? I mean, you can do it a bunch of different ways. You can do what I did, where you simply find the file. It's always the same file. It's just always going to be that. And you just write Firefox or Google Chrome in front of it. Let's say that you're not on the terminal or something. Well, what you can probably do there is simply open up. You can, where is it? How do I open File Manager? I can go inside of 1531 and my code, and I can actually just find the folder, coverage, lcov, and then I can just open up index.html like that. In VLab. Now, I'm aware that there's a handful of people in this course who, and some of you wouldn't have experienced this so far, is you do your work with VS Code SSH. So you're working locally on VS Code, but you're SSHing into the CSE machine, which means that, when you run a server or something, it's actually running on CSE. Why this is tricky is that depending on how you're set up, it might be hard for you to open up an HTML file from CSE on your own browser locally. There are probably ways around that. You could probably poke around. We can chat on the forum. But honestly, something like I would just recommend for your average person is if you are using VS Code via SSH, I would just honestly open up like a VLab window like this. I do all my development locally. But what's really cool is that if you're like using SSH VS Code, if you actually go and fix up your problems, by adding that test in, and you're on your local machine right now, you're doing all of that, and then you run your coverage again. If you just have VLab open with the web page, like I already closed the web. Oh, I closed the web. Oh no, it's open. If you have VLab open with the web page, once your coverage runs locally, you can actually just refresh the web page. You don't need to like open it again or anything. Like once the web page is open, it's just open and you can keep it there. God, it takes a while. Golly. Jeez. That's excruciatingly slow for nothing. If I refresh this, you'll now see it passes. So, yes, some of you will open up browsers locally and things, and many of you have probably experienced this already with things like Postman or ARC, and you can't connect to VLab because you're on your local machine and various other things. But again, you can just pull out VLab. You don't have to write code in VLab. You can just like check for these things in VLab and write your code locally. You can kind of set up however you'd like to set up, or you can just do everything in VLab, which is totally fine. And that's what I do. I did pretty much all of my undergraduate degree on something that made VLab look like a very, very wonderful, happy thing. So I'm sure we'll manage. Now, that was a quick throwback, just to pull that up. But, same thing applies for anything. Same on my local thing here on the leap year example, which we did in TypeScript. There is a folder called coverage, and inside that folder is an lcov report, and inside of that is a index.html file. I'm not going to open it up in a web browser here, but it's basically just a web page that has the data in it that your web browser displays, so pretty manageable. There is another example here, which is a bit more interesting. We probably won't go into a great deal of depth with, but basically there's a function called data year, where, and I'll kind of show you this really quickly. We'll probably take a break at like 7:05 or something. So if I look at this locally here, and I've got a file, 7.1 data year. Okay, relatively straightforward file. I'll give ourselves a little bit of space. Oh no. What? Just screwed up everything. Sure, whatever. Okay. If we go back a few folders, yep. Now let's make a test file for it. Now we're pretty familiar with how to make test files, right? We'll make a 7.1 is leapyear.test.ts file. Oops, sorry, I meant 7.1, what's this file called? Data year. So what this particular data year function does is it takes in a number of days since the January 1st, 1970, and it tells you what year it is. So if you say 0 days, it says it's 1970. If you say 1 day, it says it's 1970, like that. So we can open up our little test file here. Just trying to... I did this thing with the terminal where I resized it. Now it's all grumpy. I don't know if this ever happens to other people, but it certainly happens to me. So if I hear cd into that folder, yep. So I'll open up my source / 7.1 data year .test.ts. Okay, now we'll import day to year from 7.1 day to year. Then we'll do our tests as you expect. I don't know, something. That's a terrible example, but you get the point. Testing days close to 1970. Okay, so we'll test a few days with this function. We'll test if, say, I expect that calling data year and yes, the y should be capitalized on 0 days since 1970 will give me 1970 the year. We can start with that. Now, one obvious problem here is that we need to actually have this function exported. It's not currently exported, so I need to export function. Without that, it certainly wouldn't work. And then I'm going to update my package.json here to, instead of running my 7.1 is leap year, it will now run data year. Now, you don't normally have to do this because you're typically doing this in the context of a project or a lab where you can just run jest and it will just test everything, which is what you want it to do pretty much 99% of the time. But in this case, I'm going to run my week 7 test function, which should work. I probably made a mistake. Okay, so what you can see here, very interesting, is you can see that we did actually pass. In this case, I might actually open up the file. Give me a second. It's in dev, Hayden, just got to find the file. Lectures, public code. M2 coverage, this, and then we'll open it up here. So we can see the coverage in more detail. There you go. There's what we're looking for. So what you can see here is that naturally data year had, so coverage is not like a one-to-one thing where one file tests one thing and another file tests another thing. What's actually happened here, if you look at it, is that when we test our data year function, that function actually uses the isLeapYear function. So by, essentially through a chain of events, by testing data year, I checked on a certain number of lines of code inside of the isLeapYear function as well. And therefore, when we look at our test coverage result, you can see that it's saying that your single test that we did, where we tested, 0 days, actually tested 45% of data year. which is quite interesting, right? Now, we're never going to get that up particularly high, probably, because we're not trying to test that. We're really focused on this one here. And in fact, when I click on that, oops, I got those two the wrong way around. I meant is leap year, not data year. But if I click on data year, it actually will show you what we didn't test in this case. So you can see that when we tested days of 0, because days was not bigger than 365, we knew it was in 1970 because we never exceeded that. So now we need to write slightly more tests. So if we open this back up and, we can test another one, say, which is, test that day 365 should still be 1970. And then we'll say, let's test days close to 1971. So you could imagine that 366 should be the first day of 1971. So now we'll go and run our test again. And you can see the coverage is helping us inform what we're not thinking about. So when I come back to this and I refresh, you'll see that it's like, you've actually gone inside of the 365 loop, which is really cool. And because you've gone inside of that, we did check the if condition. However, because all of the kind of days or year that were passed in, which is 1971, weren't a leap year, we never went inside this particular if statement. But we did go everywhere else, which is good. Now, this doesn't tell us that the code works, but it helps us, again, understand the parts of our code that our tests are not testing. So let's go back, and let's actually test something that's a leap year. So now I'll say test leap year. So we'll test like a 1970. Actually, how would we do that? How many days? So if we got 365 days in a year times by 4. So 1 gets us to 71, 2 gets us to 72, 3 gets us to 73, and 4 gets us to 74. So it should be 1460. So this should be the first day of 1974. Now, obviously, in your test, you don't have to write this. You could just write 365 times 4. And in fact, that's probably more readable, right? Someone actually understands what you're trying to say there. So now let's see if this works. We test it with a leap year. Now this should... Oh, what have we done? Got a typo. What is the typo? Oh, okay. It's not a typo. It's just a test failure. Sorry. That should be 1973. I guess that may... Oh, sorry. We have to do plus 1 day, right? Yeah, because that'll give us, the last day of 1973. In fact, while we're here, let's turn that into a test. Let's actually, maybe this should be organized better, but now it's like 1 day past the end of 1973. So we run this one again. Okay. Still failing. We expected it to be 1974, but it was 1973. Why is that? Well, 365 days got us to the last day of 1970, last day of 1971, 72, 73, then plus 1. Not too sure. That doesn't make a lot of sense to me, right? In terms of is this a problem with our code? Probably not. Any ideas? So if we have this 1974, let's just add a few numbers to it. We can play with the boundary if we want. So plus 2. See if this is the whole problem. Maybe this will just okay, that magically passed everything. So clearly there's a slight misunderstanding there, perhaps. So if the year's 1970, if you do 365 days, you're still in 1970. But once you do the 366th day, 1970 is a leap year, obviously. Right. Okay. There's your problem, I guess. Is it? No? No, it's not. That's 1980. Okay. Never mind me. So what you can see is if we go back to our code now and you refresh it, you see that we are actually, in theory, covering everything. And this is reflected here in our data year function as getting 100%. Now, obviously, our is leap year is not, because we aren't running any tests as part of this. But if we just ran the jest coverage normally, you would actually see those tests. I can try running it like this. Oh, I can try. Let me just try npx jest coverage. Ignore the command I'm running there. Yeah, it's going to try and run a lot of stuff. quite a lot of stuff. That's why I didn't want to run it. But the point is, if we did have our other test there, this would be at 100% as well. Now, there is actually a subtle bug in this code. I believe it's related to a fairly famous bug. If you want to dig for it, you can. It's an infinite loop. If you get this code wrong, I'm pretty sure there's an infinite loop somewhere. So if you're bored sometime, feel free to go and play around with that. Find the infinite loop in the code. But that's just another example of where we can use code coverage to help us figure out what we're not testing. And to my point again, in summary, you know there's the -- coverage command. You can put this in your package.json. There's an index.html file that actually gives you that information. Brendan has said will we be assessed on this in our project? You will be assessed on this in iteration 3, not iteration 2. So come iteration 3, you will also have your test coverage assessed. But that's okay, because if you improve your test coverage, you probably improve your automark as well. And the summary to give on this again is that test coverage is essentially how well your tests what's in the spec, whereas code coverage is how much of your code your tests actually go through. Hello Clayton says, will we learn how to apply coverage to requests and web servers? That's a good question. It's actually like identical. I don't think this will work on VLab. Sorry, not quite identical. Let me elaborate on that slightly. So, and I'm a bit worried this will blow up in my face because of that strange error. But if you actually go to your package.json, and we will give you this in iteration, you'll see this in lab 8 and in iteration 3. There is actually a command here which we get you to run, and it's part of the spec. So like we can talk about this next week when we talk about iteration 3. I won't go into it too much now because it's kind of easier to go into when people are paying attention and remember. But essentially we've got this really fancy confusing command for you where instead of running TS node on server, you just run TS node coverage. So if you think about how you run your server, right? npm run TS node, source/server.ts. You kind of run that over here. It's not a real file. It's why it failed. And then in another terminal, you run your npm run jest, and it goes and runs it all against your server. Quite literally, for iteration 3, it's as simple as instead of running jest, you run jest-coverage, and instead of running ts node, you run ts node coverage. This is a bit annoying that we need to use this, but it's some kind of magic that essentially is required because it's a web server. But it's basically the same. There's so to the point, to apply it to our web server, it's actually quite literally the same. Your tests run. It's just that there's this one extra command. But again, this is all written into the iteration 3 spec and the code push and stuff. So there's nothing crazy that we expect you to just kind of come up with. So we will support you very well there. Now, last couple of things. Branch coverage. Sorry, just before I move on. So Clayton said, all my coverage is getting 0% at the moment. It's probably because it's not running it with this command. So like myself and the course staff went through quite extensive testing when we were writing this course. And we found tons of problems that we all fixed up. And this was part of it, was that web servers are a bit weird, and because it was a web server, the coverage wasn't keeping track of what was seen in the code or something like that. But again, this was all fixed by just running our command. So don't stress too much if you just add coverage to your iteration 2. This is probably a great point. If you just go and add coverage to your iteration 2 and it says 0, don't worry. I'm pretty sure Lab 8 covers this stuff. Yeah. But if, iteration 3 is coming out on Monday, you don't have to worry about coverage. Many of you, from what we've seen with the tests, have pretty good coverage anyway, so it should be fine. One thing that's interesting, though, is this topic of branch coverage. Now, branch coverage is really interesting because branch coverage looks not at the number of lines of code, but essentially at the number of branches in your code. Now, branch, don't confuse this for a second with a Git branch, because a Git branch is something completely different. A branch is essentially a while loop or a for loop or something else. it is where you... Actually, I realized... No, we talk about that later in the course. Branch coverage is where you look at code not from a number of lines, but how many possible branches there are. Now, a really good example of this is actually if we go back to our code here. This piece of code, this function, whilst it does have, 8 or 9 lines of code, this is statement coverage or line coverage. But branch coverage actually looks at this piece of code and said there's actually only 2 ways this code can go. It can either come into the if statement, right, and come through there and then finish, or it can skip the if statement and finish. And what you often find is that branches are often where things go wrong. And what we mean by that is that if this line of code is correct, if this line of code is passed through, the rest of the lines of code tend to be passed through. So when you look at a function like this that doesn't ever make it into the if statement, and you say something like, oh, it's 80% correct. And we saw this up here when you kind of look at some of the older results. 87.5% correct. That's a little bit deceiving because that percentage gets bigger if I copy and paste these lines of code another 5 times, But branch coverage here is 50% because there's only really 2 ways this function can go and you've missed one of them. So it's just a different way of reporting. So it's the same coverage, it's just... Like branch coverage doesn't do anything different. It's just the way it summarizes your results are different. Branch coverage is kind of arguably better. This line done automatically with jest is true, though, and we used to actually do branch coverage by default as our judging mechanism in this course with Python and PyCoverage, but there's some limitations of how jest works that I'm just not going to go into extensively, but it essentially... It doesn't do branch coverage how you'd expect sometimes. I don't know if I go so far as to say it's a bug, but the behavior of how jest does branch coverage is not consistent with what we believe branch coverage is. So for that reason, branch coverage is something that's really interesting, and you should engage with it, in your career and later on as something that really matters. But for the sake of this course, we will be looking at statement. We were looking at the statements lines thing, the 87.5%. That's what we will be looking at. So in summary, code coverage is useful. It's more important to look at what's not covered than the coverage percentage. Yeah, so don't get too caught up on the percentage. Focus more on the lines of code it hasn't covered and go check them out because they might be really critical. Branch coverage is more accurate, so you should use it if you can, but you can't in this course. And like all measurements, it's important you understand what it's saying because sometimes there's just code that you can't reach or something else kind of obscure. So that's pretty much it on code coverage. I appreciate your patience amidst the weird CSE issue. That's a bit annoying with TypeScript. Apologies about that. We will talk about coverage again when we talk about iteration 3 next week. Again, everything in this is all tied to iteration 3. It has nothing to do with iteration 2. It's completely unrelated to iteration 2. So if you could please provide some feedback, that would be great. And yeah, we'll keep chatting about this. But overall, pretty straightforward topic. Pretty cool idea. Fairly straightforward commands. And very powerful to help you reduce errors in your code.